Hi everyone, I'm Luis Duarte. I'm a systems engineer here. I'm going to talk more about me in a bit. I'm going to talk about porting a Rust crate to workers, how we got Diesel, which is a ORM, to work with D1. First, a bit about me. I'm 21 years old. I'm young. I'm from Perth. I work on email routing, workflows, and on my spare time, I try to improve Rust workers. First, some context. Sven showed a beautiful demonstration what you can do with D1. So D1 is our managed serverless uh, a database. It uses SQLite semantics, and it has some cool stuff. So you can time travel, you can use workers as Sven demonstrated, and you can even use it through an API. It offers a generous free tier, and it has a great developer experience, and it can empower you to develop workers with actual stateful operations. It's not the only storage thing on Cloudflare. There's KV, R2, and other storage products that can empower workers. The one is the SQL one. So getting started, it's really easy. Sven showed this. You create a database, you add it to Wrangler, and then, okay, you can see it. And then you interact with it. It's easy, right? But writing SQL queries can be a bit hard, not on actually writing them. Most of them are quite simple, but they are difficult to guarantee correctness. A schema migration might cause your old queries to not work anymore and you blow up the system. It happened to me not so long ago. You can making dynamic queries without making some obvious SQL injections it's not easy. You can think of dynamically adding filters or adding pagination and stuff like that. And if you use TypeScript, your types are probably not validated or generated from the SQL schema. So you might have differences with your types, even if you use TypeScript, and your SQL schema. And some stuff like this can happen. We all did it before, hopefully not in production though. But it's a mostly solved problem, right? There's even in JavaScript, there's workers KB, which is a zero dependencies query builder that Gabriel is back there built. There's also Drizzle, which is a TypeScript-based ORM that tries to do some relational mapping and do most of the work for you. But uh, your queries might be safer, but your business logic might not. And I think there's where Rust can enter. And what I love about Rust, you have real zero cost abstractions. You probably can't write a vector faster than the standard library. You can't probably write a map faster than the standard library. Yeah, and you can't easily coerce types like in TypeScript. In TypeScript, you can make a number an object and stuff will blow up because someone did that. And this statically typed thing will become important later, but it has some great functional primitives like result and option that come from functional languages. There's no garbage collector like in JavaScript, so your memory allocations are done like in C++, but there's a thing called the borrow checker, which checks if your variables are safe to use, if they are not memory leaks. And it's usually portable. You can write once, run anywhere, a native code or WebAssembly code. Uh, if you use your primitives right. It has great community support. You have crates.io. It's the NPM equivalent. The thing I love the most about crates.io, it's because you can express domain specific stuff more easily in Rust. So even if a crate is unmaintained for a year, it's probably safe enough to use. Probably not recommended, but if it follows the paradigm of write once and kind of forget it. except for vulnerabilities, of course. In npm, for instance, you can't do that. If you use a library that's a year old, no one maintains it, probably it doesn't work with the latest TypeScript version or something related. And it's blazingly fast. It compiles down to assembly code. It has similar performance to other compiled languages, so there's no really real cost here. So the same example, a bit modified, but let's think about what can go wrong here. So first we get you guys can see it, right? Yeah. Uh, First you get the path name, and Cloudflare workers gives you always the correct URL. So there's not probably there isn't there isn't something there. You match against the path name, and you do a SQL database. Uh, the SQL database might not be valid, for instance. It probably is. It doesn't matter. You also do a bind call, and you try to deserialize the body into an object and call .company. .company might not exist. The .all call might fail. And the thing I love the most about Rust, and there's some stuff I don't like, which I will go on later, is the errors are explicitly expressed. So it's a really simple function. It's just a square root, and you can't take a square root of a negative number. So you can express it as a result of an OK value and the error value. This allows you to write very expressive operations, because you can, to destructure the result, you can do two things. You assume that it's correct, and if it's not at runtime, your code will crash, which is probably what you don't want to do. Or you can match against the result and say, if it's okay, probably just return the result. If it's not okay, return a 500 or return an error to the user. It's really explicit on your operations, and it's really useful, especially if you have to do a lot of calls to another services or libraries. So Diesel, I've talked Diesel in the title, and Diesel is an ORM that gets rid of all the boilerplate of writing SQL queries, tries to eliminate runtime errors, uh, except like constraint errors. That's a bit database related, and it doesn't sacrifice performance. It really takes in the zero cost abstraction part. And it feels like Rust, and I can show you guys the examples from the website. Um, you can do complex queries for multiple objects. You can do custom filters. You can do custom orders, and it generates SQL that's fast enough, and probably you can't write it better. And it's really, really extensible. People say that Diesel isn't a full ORM, at least on the traditional sense. You have ORMs like the Laravel one, the Django one, that really try to connect objects together and do all things for you. It's not what Diesel tries to do. It tries to abstract queries. But there are extensions, and lots of extensions, to generate Rust structs from schema files. If you want to use Rust enums with Diesel, for instance, or if you want to use asynchronous Rust if your database is asynchronous, like D1 is. Spoiler alert. And there's cool stuff written in using Diesel. There's crates.io, there's Vault-Warden, which both are really famous, and you also have Lemmy, which is the decentralized version of Reddit, I think. So introducing Diesel D1, it's a backend and connection layer. It's it takes the components from Diesel and tries to build a connection layer that you can use Diesel with. It's pretty much in an MVP stage. It needs some polish, some correct error handling that I didn't have the time to do. And for now, it only leverages the worker binding. So it only works for Rust workers. In the future, I probably want to also add support for the API for other platforms. So I will do a really quick demo. Um, this is to make it larger, probably. Uh, Good enough. Yeah. So let's start from the beginning. I have somewhat a complete example because I'm not as good as live coding. I, but it's the same concept as Sven. You have a router that does a get and a post. It has some state, which in this case, I pass in the worker environment itself. And on each endpoint handler, I grab the states, but I'm using a library called Axon, and Axon tries to do something really cool. And you can see it in create. You can pass uh, any struct that's serializable or deserializable. You have to mark it like I did here as serializable. And it automatically does header checking to check if the content type is correct, if the JSON is correct, if it has all the parameters. So here, in a simple line of code, you do lots of things. I think it even says in the documentation. Yeah. Um, and then I create a connection using the environment and the binding. This comes from my library. And then we can use the normal Diesel stuff. We can insert into a table with some values and execute a connection. So it seems pretty similar. I don't have to write SQL. I can do some dynamic filters, especially in the get. I can do dot filter. I'm just fiddling around. Uh, I don't have type checking because my PC is slow. Sorry about that. But it's a basic example. The magic here comes from the schema. And I think it's one of the advantages of using Rust. You can create almost domain-specific languages for, in this case, for generating tables, and it automatically can generate the migration for you, or you can do the opposite. You can generate the migration and then come from the and then do generate the schema. And it has some. There's extensions to generate the structs, the translation between the SQL and the Rust parts. I did it by hand. I didn't want to use the extension to basically anything that's a table. You want to make it queryable. You want to specify the table name, and this comes from the schema file that you define in this beautiful schema language. You can use things that are not in SQLite. You can use varchars, and it will work because Diesel knows that it's in this dialect. Only text exists in SQLite. For instance, bools don't exist in SQLite, and it's just an integer. Diesel does that for you. It's the really cool part about Diesel is that we can migrate from Postgres to SQLite to Postgres or MySQL, or write your own database layer and put it on Diesel, and it will work. It's really modular. There's lots of extensions for everything pretty much. You can generate, instead of writing SQL for migrations, you can even write Rust and it generates the SQL. I didn't want to do that because it would be way too complex, and it's not the objective here. It's just the end goal. So basically, to show that it works, and I can go to the next part, let me just reset it. And now I can do Wrangler dev and make it bigger. it will warn me about things that I'm not using currently. But it started, and I'm going to pull out. I don't have a fancy UI. Sven outdid himself on that. So I have a good old curl interface that I can get the posts from. And I can get the. I have to open another tab. And I can see if I have a database, even, because I honestly don't remember. Um, so it's not this one. I hate live coding. Okay, there's a database. It's defined, and now I want to apply the migrations if those exist. So I'm going to regenerate migrations. I'm going to make the template available, and I can do just my caps lock button. It's reversed. Regenerate. And it will copy the migrations from the diesel generated migrations to to the to a format that Wrangler can understand. It's a simple bash script that does that. And now I can do the same command as vending slash /s local, and I want to run on db caps lock. It's really messing me. It's like the opposite of my caps lock is doing the opposite. Migrations. Come on. It's apply. Classic. And now there's a migration to be applied. I apply it. It does it successfully. I can do it remotely. And now I can query. This is my production one. I could use it, but I wanted to make it live. Let's assume that it works. I've done a post and it appears here. It works flawlessly. One thing that's also cool about Rust is that you can do partial structs using the table. So here I use the title and the body because I don't want the user to insert an ID, for instance, or I don't want the user to say if it's published or not. But I get type safety in the sense that it checks against the SQL schema. So if I try to do U64, a number, it will error out and say, yeah, I'm expecting a text. So I have to use a string. And you get type checking. If you change the schema, it will change the schema file and the models will be all correct. So it's really the advantage here. But how can you port something like Diesel into Cloudflare workers? First, we need to know the constraints about Cloudflare workers. They have one CPU thread. You get 30 CPU seconds per request. And what I mean by CPU seconds, you can think of it as 30 seconds of CPU cycles. You get 128 megabytes of RAM, and you almost don't get cold starts because workers starts really fast, and the time that it takes up to load the JavaScript and WASM code, we do it during the client's TLS handshake. So there's really no cold starts here compared to other serverless platforms. And there's also a nice upside. You only get charged for the CPU cycles, for the CPU seconds that you use. So if you need to wait for a AI inference to run and it takes 30 seconds, you are not charged 30 seconds. You are charged for the processing time. It can be 2-3 milliseconds depending on your worker. And how Rust workers work. First, we have our workers platform. It's called Workerd. It's built on top of V8. It has all the bindings code that connects to databases, AI, and some other stuff. But V8 expects JavaScript and we want to run Rust. So there's some JS glue embedded here. Um, it's mostly generated from Wasm Bytegen, which is a really nice crate. It does basically everything for you. If you dip, and I'm going to go to the code itself. So this is the bindings. This is most of the Wasm Bytegen code. I can define unsafe code because dealing with JavaScript in Wasm's perspective is always unsafe, and I can define the result success. I define basically I get the types from the JavaScript side and I paste them here in this format, and we get some cool stuff. We get those fancy results where you can see. Okay, I will try to get the count the the execution, the result of the execution, but something might go wrong. And Rust is very explicit here. We see that it's a result of an option of integer. And the second part is a JS value. It's a JavaScript error. It's really explicit on what JavaScript or anything can return, and you have to handle that. I will show that in a second. And we also have some workers RS specific shims to make it work with the entry points that we must expose to the workers platform. And because of this, there are some inherent limitation of Rust workers, and they were more prevalent years ago, but the Rust community now writes abstract async stuff. So you can't use Tokyo, you can't use async STD. If you know those, they are custom async runtimes because Rust doesn't offer you async runtime for you. You have to provide that. And in case of Rust workers, it piggybacks on the V8 promises side, and we provide that for you. We do a translation between promises and futures. And you can't trivially use, for instance, POSIX system calls, but you can emulate them. There's projects like mscriptum that can do that for you. And because workers, like I said, you only have a single thread, we can do some skipping of hurdles. We can force the send and sync traits. And for those that are not initiated in Rust, async stuff in Rust it's assumed to be multi-threaded. So in case of workers, we don't want to deal with the burden that is to do mutexes and other stuff to guarantee that it will be memory safe across threads if they are no threads, right? So we can do some unsafe implementations of send, which is in this case sending the value between workers, or sync, which is synchronizing the value between workers. This is safe exclusively under Wasm if you are running in a single-threaded environment. You can add configs that make this only available, this hack, let's say. It's not a hack, you know more than the compiler in this case. That's why you write unsafe. And you can only make it so that this hack works on Wasm. And the same goes from promises. I discovered this while implementing Diesel. Futures, because they are JS values and because JS is also single-threaded, but Wasm doesn't know that. So everything that comes from JavaScript is assumed to be not sync. And because the Diesel async crate uses the async trait crate, it's a crate that automates some async stuff for you. It assumes that the values must be sendable, but it's not the case with futures. So we do the same hack that only applies to WebAssembly, and because we are running in the single-threaded environment. So let's go to some specific Diesel challenges. First, you have to sign away your life. It's a very nice feature. You have to say, I implement a third-party backend and opt in to break-in changes. It has probably some fancy lore. Probably the crate maintainer got mad for someone, so they did that. And Diesel doesn't R depend on any async runtime. In fact, Diesel is synchronous, and it was built on the time that async Rust wasn't a thing yet. Async support, of course, is added through the Diesel async crate. It's written by the same guy, and it seemed really easy to port because you can see there's a I have the the caps lock inversed again, Diesel, and you can see there's a Diesel backend. I when I saw this before this meetup, I thought to myself, "Oh, this is going to be easy because D1 uses SQL, the SQL dialect. I can probably reuse most stuff." I couldn't be more wrong, by the way. And here comes the fancy zero abstractions way of writing Rust, of writing these kinds of libraries, where you try to write generics in the way that everything is done for you at compile time. So here I have to always specify that I am using the D1 backend, and it applies for almost everything that's related to Diesel, and it's partially what made me implement all of this by hand. But Diesel has some cool stuff. For instance, in the backend, which is we define the SQL dialect, and this is really powerful because I can go from Postgres to a SQLite based dialect, or even create my own dialects, and I have to write a parser for it, and it's really powerful because it's really extensible, and because it uses generics, it uses types, it's all done at compile time. At runtime, you don't get indirections and stuff like that. And one of the other reasons that the SQLite backend didn't work for me, it expected the SQLite C functions. So I didn't have those, of course, for using D1. So I had to do it by hand. Transactions are not easy to do because D1 officially doesn't support them. You can batch queries and it runs under a transaction. It's what I do, but you can't use the start transaction and commit transaction stuff. So you have to do some work around it. Migration harness is not synchronous. It's the part that does migrations, and it's difficult to integrate because D1 is asynchronous. So doing that layer by hand is really difficult. And what's the future of Diesel D1? First, we want to implement HTTP API, and this makes the D1 available for other platforms. I can use x86 native code to interact with D1, for instance. I still have to add some missing SQLite features, try to investigate transaction support, and try to natively handle migrations in a more idiomatic way. And it's the end, right? It's not. And it's a cool idea that I've had while implementing this. So recently, Durable Objects added a sync SQL API. And Durable Objects, if you are not familiar with them, you can think of Durable Objects as a really small container or a really small computer. But it's useful when you want to do something that we do in workflows. We divide every user gets its own database that controls state. We shard it that way, and we don't have to worry about a single Postgres instance that gets overloaded with all the users. Every user gets its own SQL database. And this will come very handy in the sense that you can have literally millions of DOs and it's supported. So, but imagine handling the migrations for all of them. And if you use query builders and ORMs, this becomes more easy. And I think it's the end target of Diesel D1 and Diesel DO. Most of the code can be shared between those two.